Hi guys. Hi guys. Good evening. Am I audible, Amar sir?
Yes, sir.
Okay then. We'll start.
Yes, sir, we can start.
The students of Molarity College has joined.
Yeah, yes.
Okay. I'll just start sharing my screen in some time and we'll start.
अभी क्या एक और अपना पार्टनर है, क्या नाम है?
Are you able to see my screen, guys? Okay, so I'll make a day 2 today. Okay. And today we will try to do the searching and sorting techniques. Okay. So I hope you are aware of the various searching and sorting techniques. So we will be using a lot of them in our programs. So let me prepare a fresh paint screen for you guys. Okay. So I can share it. So on the chat, you can drop and let me know as to are you able to see my notepad screen. Okay. So we have various sorting. Okay, first let's do the sorting algorithms. So I hope you all are aware of some sorting algorithms which we use. Okay. So sorting techniques. Can you all name two sorting techniques for me? Whatever you all know from the chat, you can put it. Okay, so we have various sorting techniques. So selection sort, bubble sort, insertion sort, okay, merge sort, quick sort. So we can use many, there are many more. Okay, there's counting sort, bucket sort, radix sort. The list goes on and on. There are many ways which we can do it. So even if you know handful of them, even if you know the first four, okay, even if you know the first four is more than sufficient for your data structure algorithms. So we'll try to do program on the top four today. And once we finish sorting, we will take searching techniques. So what are the two famous searching techniques? Yes, guys. Linear search. And second is your binary search. So I hope you all are aware of these jargons. So anybody over here who hasn't done any practical on any of them, so I will not assume anything. I will try to start from the basic level. But if you all have fair idea as to how this operates, then I will try to go a little bit faster. So you all can set the pace for the session. So by giving your input to me, as we are in the initial sessions. So once I get the input from you guys, I can pace my sessions accordingly. So on the chat, you all can drop the messages to me. Those who have joined over Zoom can drop direct messages and communicate as to how we need to pace these sessions. Because the end result, we should benefit from these sessions, right? We should get the confidence of solving the first round of interview programming questions, which comes from lead code. So that is the main purpose of conducting these sessions. Yes, guys. I'm waiting for your chats so I can pace my sessions accordingly. Because last time I had got few reviews that try to go a little bit slow. People are still joining in. Okay. Meanwhile, as they join, and you all can send in your feedbacks. I'll start with the first sorting technique that is called as selection sort. Okay, so I'll throw all the animation version also, and then we'll do the programming also on them, and then some programming questions later on. So if this is my array and I have random numbers stored in the array, okay, let's take any random number, 6, 7, 2, 5, 3. Now I need to sort them. So how do I sort them? Using first technique that is called as selection sort. So I'll just take a little bit up. The first technique we are using is selection sort. So what happens in selection sort is the first number compares with all the remaining numbers in the array. So if I have these numbers, right? So I'll write them down. So these are my unsorted numbers. 6, 2, 5, 3. But I'm in the first iteration. So these are my unsorted numbers. So what we have to do is hammer a nail at the first unsorted element. So it's like hammering a nail at the first unsorted element. I take a nail and I hammer it over here. And now compare that element with all the elements. 6 with 7. If the number in front is larger, then you swap. So is 6 larger than 7? No. Then you write it as it is. So you will swap when the number in front is greater. So as 6 is smaller than 7, no need for swapping. Now next, what will you compare? First unsorted number with all the numbers. 6 with 2. Now is 6 greater than 2? Yes, then you will swap. So whatever you compare, you swap them. So 2 swaps with 6. And the remaining numbers at their original place. 7 at its place. And 5 at 3 also at their respective places. Then next, what do you think will compare? 2. Okay, the first position, right? So always over here, first position with all the positions. So 2 with 5. Do I need to swap? Yes, guys, I would want your participation, guys. Will I swap? Yes or no? So no need to swap, right? Yes. So number as it is. And then next, what do I compare? 2 with 3. Do I need to swap? No. So it remains as it is. Okay. And now after my first iteration, my smallest number I have got in front. And my first iteration is complete. Now what are my unsorted elements? These are my unsorted elements. So I take them and here. Okay. Now I will hammer the nail. I'll hammer the nail at the first position of the unsorted elements over here. And now I'll compare what? 7 with 6. So 7 with 6. Do I need to swap? Yes, because 7 is greater than 6. So I will write 6, 7, and remaining two number on their respective place. Next, what will I compare? 6 with 5. Do I need to swap? Yes. So 5 comes over here and 6 goes over here. Remaining number at the original place. 7 at the original place and 3 at its original place. Okay. The next, what will I compare? 5 with 3. Do I need to swap? Yes. So 3 comes at 5's place and 5 goes at 3's place because of swapping. And remaining 2 at the original place. 7 at its original place and 6 at its original place. And now there are no more iterations. So I've got my second smallest number also. That is my end of iteration 2. So here you have to just observe the lane discipline. That is the crux in your sorting. Just observe the lane discipline. Now which numbers are unsorted? 7, 6, 5. I take them over here. Okay, then I compare 7 with 6. And as 7 is greater than 6, I will swap it. So I will have 6, 7, 5. Six, 7, and 5. And next, what will I compare? 6 with 5. So is 6 greater than 5? Yes. So I'll write 5 and 6 will swap 7 at its original place. Okay, and after this iteration, I have got my third smallest number also. And my iteration also completes. Now what are my unsorted elements? 7 and 6. So I take 7 and 6 and you know it will to hammer the nail. Nail will be hammered at the first unsorted element. So it got hammered over here. Then over here again. Then now again over here. So 7 and 6 is greater. Here it will swap to 6 and 7. And now I've got my fourth highest number also in place. Now this is my end of iteration number 4. Okay. Then I have only one unsorted element left. That is 7. And there are no more comparisons to be made. So I will say this also is sorted. And my output of the program will be 2, 3, 5, 6, 7, right? So like this, my selection sort has, this is the theoretical part of it. So now let's try to write a program for selection sort. Okay. So here you should remember the one in the green are the number of iterations. So when I have 5 numbers, I will have those many iterations. Okay. So this is my iteration number 1. And this is iteration number 2. Iteration number 3. Iteration number 4. And iteration number 5. So the size of the array, those many iterations. So whatever was in the green is the iterations, and whatever is in the red is the comparison. So in the first iteration, how many comparison did I make? If you observe, I made in the first iteration 4 comparisons. Okay, and then gradually the comparison count reduced. So 4 comparisons, then comparison came to 3, then comparison came to 2, then comparison came to 1, and then comparison came to 0. There was no comparison at all. Okay, so whenever we are doing selection sort, we will observe that we have nested for loop. So we have a for loop inside another for loop. So we have nested for loop sort of programming structure. And whenever you have a nested for loop programming arrangement, the time complexity will come in O of n square. So now what do I write in the outer for loop and what do I write in the inner for loop? So in the outer for loop, you write number of iterations. What do you write in the outer for loop? Number of iterations. And in the inner for loop, you write number of comparisons. Okay. So like this. So in the outer for loop, you write number of iterations, and the inner for loop, you write number of comparisons. So here, how many iterations do I have? How many iterations do I have over here? 5. So I will write the outer for loop as integer I equals to 0, I less than ARR dot length, which is 5, and I plus plus this array. And then inner for loop, what will I write? Comparison. So comparison is reducing in each iteration, correct? So I will write over here as, and what am I comparing over here? Yes. So I'm comparing the neighboring one. Okay. So I will say my j is equal to I plus 1 and j less than ARR dot length and j plus. Okay. So this is my I, this is my I. So in the first iteration, I is at 0, I is at 6, and j is just one step ahead of I. So j is at 7. And j will increment first, and then j will go to 2. Then j will go to 5, and then j will go to 3. Okay, and as I'm starting from one step ahead, so this loop will go from 0, 1, 2, 3, 4. Okay, less than we have given, right? So this will go 5 times. And the first iteration, this will go from where? 0 plus 1. So starting from 1. So we'll go 1, 2, 3, 4 times. When second iteration, when I becomes 1, it will start from 1. 1 plus 1 is 2. So it will go, second iteration, it will go 2, 3, 4. 3 times. Third iteration, it will go 3, 4. 2 times. And in the last iteration, it will go only once, 4. And fifth, it will not go at all. So like this, you in back of the mind, you should know what is happening behind the scenes. Okay. So this would be my switch case for your selection sort. So let me come here and I've made a package by day 2. I'll refactor it and maybe give a proper name, refactor it and rename it day 2, and I will give sorting. And here in the sorting package, we'll make a new class and we'll name it as what? Selection sort. Okay. So let's take the array. So who can help me with the numbers of the array? 6, 7, 2, 5, 3. 6, 7, 2, 5, 3. And now I'll call a function called as selection sort, and I'll pass this array to that. Okay. So before sorting, we can write over here before, and I'll display arrays dot toString and the array. And once the array gets sorted, I'll display it again by saying after. Okay, and now let's write this function. So this function has now got the array. And now what are my for loops? I'll just copy this and I'll paste it over here. Comment these out. The first iteration, I equal to 0, I less than AR order 10, I plus plus, J equal to 1 step ahead, length. Okay. We'll take a temp variable also because for swapping, we'll need it. So when will I swap it? If the element at ARR of I is greater than the element at ARR of J. Okay. Then how do we swap? ARR of I goes into temp. ARR of J goes into I, and ARR of and temp goes into ARR of J. Like this you will swap. As simple as that. Okay. Do you know what is call by value, call by reference, guys? Array is reference type. So if the function is modifying the array, it actually modifies the original array. That is called as call by reference. So if the changes is taking place in the formal parameter, the actual parameter also gets impacted. So I am swapping the array over here in this ARR. If I name it to BRR, if I name it to BRR also, and here I am modifying the BRR array, but as arrays are called by reference, it will impact the original array. So BRR and ARR are pointing to the same address. So array is passed as a reference, not as value. Okay. Yeah, perfect. Let's save it and let's try to run this code and check if it's running fine. And here you go. Before it was 67253, and after it is 23567. Okay, so I'll do a program. I'll give you all a 2-3 minutes gap to practice the program, and then we'll go ahead with the next program. So our main objective is that you all get into the mold of programming, and such complex program which we will do later on should be very easy for you all to understand. That is the main agenda, what I plan. So I'll do a program. I'll pause my screen. Maybe I'll push the code to the GitHub repository. I had shared the repository link with you all, right? So on Friday, I had shared the repository link. I'll again publish today's code also. Where is our day 2? So those who wish to see the code, they can see it from this repository. Let me reshare the repository link with you all. So this will be more programming session. So I want you all to get your hand dirty with programming, guys. So just mere theoretical understanding of the subject will not be of that much help. We need to get our hands dirty with programming. So I've shared the GitHub link, refresh the GitHub link. So if you go to the GitHub link, okay, this is the GitHub DSA Mastery with Java. Go to SRC and you'll see a package over here, day 2 sorting, and you can go over there and you will get sorting.java and the code will show over here. So even though if I do not share my screen, you still can continue practicing your programming. Okay. So we'll do here. See this is what I plan to do. Okay. So we'll do a little bit of theory, explain the concept on the whiteboard. Once a concept explanation is done, okay, this will be a step 1. Then whatever concept we have explained, we will program that. Step 2 and step 3, I will give you all time so that you all can spend some time practicing the same program. Come on now. Program this for 2-3 minutes now. Okay, guys, this is acceptable for you guys. Anything else you want to share, your review, feedback? So accordingly, I'll add that into the training module and then pace my session accordingly. Let me see what the YouTube guys have to share. Okay, the Zoom guys can send their feedback on the chat, whatever they want to say. Yes, no, maybe, good, bad, whatever. And now let me revert to the, let's see what the YouTube guys have to say. Purvi, in bubble sort, the comparison count is different. It will move in a different manner. Okay, I'll show you what is bubble sort also. Yes, you're right. This is a selection sort, what we discussed. So I guess Purvi has some doubt in bubble and selection. So we'll try to sort that out. The way she is texted, she sounds very confident. So we'll try to, give a reality check as to what exactly is the concept. Okay, so this pace works for you all, right? Perfect. So let's me go back. I'm audible to you all on YouTube, right, guys? Because I flips comparison both will have Samsung. It's just the pattern of comparison varies. Both will have comparison. All the sorting techniques will be based on comparison. That is, the primitive operation is comparison internally. It's just that what pattern you are comparing, that is the difference. Okay. So, okay, then I've written the random chats from YouTube, and these guys are pretty much satisfied and happy. Okay, Junaid. It's showing over here Samsung. So maybe you logged in with a Samsung machine, looks like mobile phone. Annie, your array is sorted in descending order because you might have used the comparison operator differently. I guess you have written ARR of I less than ARR of J. So try to switch the comparison operator from less than to greater than, and it will be. YouTube guys are pretty active compared to the Zoom chats. I see a lot of comments and people are practicing. Thank you, Junaid. So, and you just reverse the order of the relation operator in the if statement. I've written ARR of I greater than ARR of J. I guess you have written it otherwise. Just reverse that and your array will be sorted in ascending order. Once done, just post on the chat, Annie. Got it? Is it working? Have you got the desired output? Yeah, perfect. Okay, guys. Yeah. So even you all can send in your queries over the chat, and I'll try to pace my session accordingly. Okay. So let me now share my screen. I was reading the chats on YouTube all this while. I'll come back over here. I was just reading these chats. Okay. So what people had to say. So now let me come back to the programming. So this was selection sort. Okay. People have a bit of doubt in bubble sort. So let me just try to replicate this with a bubble sort also. Okay. So I'll take the same number 67253. Okay. Who has photographic memory can repeat the numbers to me when I share over here. 67253, right? 67253. 67253. Yeah. So in bubble sort, what happens is the why the name bubble comes. Okay. There are many theories behind it. What I have learned, the reason why the name bubble is, so if you take a pond and if you throw a stone in the pond, okay, you just throw a stone in the pond, it will create ripples. It will create ripples, and the ripples will reach till the end of the pond. So when the bubble will burst, the ripples will reach till the end of the pond. Okay, this is one example. Second example is if a large fish, okay, let's say a whale dies inside the ocean, the waves, what they do? The waves will wash away this shark or the whale to the seashore. The first wave will come, will move it slightly. Second wave will come, will move it slightly. Third wave will come, will move it slightly. And then eventually it will be washed away at the beach. So you might have seen some videos of YouTubers wherein they show a dead whale is lying on the beach. So how did it reach from the center of the ocean till the seashore? Waves, pushed it one wave at a time. So bubble sort works primarily on this logic. So what we do in bubble sort is 6 compares with 7. Is it greater? Yes or no? No. So no shuffling, no swapping, right? So, and now this is where the difference lies. 7 will now compare with 2. So like a bubble, like a wave, it keeps on moving. Purvi, so this is the difference. What were we doing in selection sort? Comparing the first number with all the numbers, right? But here in bubble sort, you have to move ahead. You have to progress. This is your bubble sort. So here you have to move ahead. So now 7 with 2, is it greater? Yes. So you will swap over here. So 6 at its original place and 5 and 3 at their original place. What you are not comparing, you will not swap. What you are not comparing, you will not swap. 5 and 3 at their original place. You will only swap what you are comparing. You only swap what you are comparing. So 5 at your original place and 3 at your original place. Okay. The alignment should be very proper in your sorting, so you understand better. Now, is 7 greater than 2? Yes. So what you do then? You swap. 2 and 7 swap their place. Okay, now tell me, what should be the next iteration? What do you compare? Like a bubble, you have to move forward. Like a wave, you need to keep on moving forward. So, you will compare 7 with 5. Absolutely correct. And then, do I need to swap? Yes, 7 is greater than 5, you swap. So 6 at its original place, 2 at its original place. Whatever you have compared, if the number is greater in front, then you swap it. So 5 swaps with 7 and 3 at its original place, right? Then next, what do you compare? Next, you compare is 7 with 3. Now, do I need to swap this? Yes. So 6, 2, 3 at their original places. 6, 2, 5 at the original place. And 3 and 7 will swap. And now after the first iteration, my biggest number has got its place and my biggest number has been washed away till the seashore. And my biggest number I have got over here. Screen is not visible. Now, how is it visible? Yeah, guys, please, keep on telling me. Yeah, thanks, Revan. So now my first iteration is done. And I've got the maximum number at the end. Now, what are my unsorted elements? These are my unsorted elements. I will copy them for the next iteration. And again, the cycle will repeat from the start. So now what will I compare now? I'll compare 6 with 2. Do I need to swap? Yes, I need to swap because 6 is greater than 2. So 2 over here and 6 over here. And 5, 3 over here. The next 6 with 5. Do I need to swap? Yes. So 2 at its original place. 5 and 6 will swap. And 3 at its original place. Then the next iteration, 6 compared with 3. Do I need to swap? Yes, because 6 is greater than 3. So 2 at its original place, 5 at its original place, we will swap 3 and 6. Okay. And now I have got my second largest number also. at its desired location. And my second iteration also is complete. And now, what are my unsorted elements? 2, 3, 5. So I'll write them and again start the comparison from the start. So 2 compared with 5. Do I need to swap? No need to swap because 2 is less than 5. So as it is, you can place all of them. Then next, what will I compare? 5 with 3. So 5 is greater than 3. So you will swap. So 2 at its original place. 3 and 5 will swap. And now my third largest number also has got its place. And my third iteration completes. Now what are my unsorted elements? 2 and 3. Okay, so I'll compare 2 and 3. Do I need to swap? No swapping. So place it as it is. And now my third. Okay. This number also I have got now. And now I'm left with only one number. And there are no more comparisons to be made. So I'll copy it as it is. And I'll say I've got the number. So now I've got 2, 3, 5, 6, 7. Right? This is my bubble sort. So now if I go for the comparison, as I said, the outer loop will keep a count of the iterations. How many iterations do I have? The outer loop will keep a count of the iteration. So how many iterations do I have, guys? Who will tell me? So I have 5 iterations, right? So I'll do for integer I equals to 1, I less than equal to 5, I plus plus. This loop will run 5 times. Okay. And 5 times I need to get my j back to 0. Okay. 5 times I need to get my j back to 0. So I will say for j equal to 0, j less than, iteration count is reduced, right? So 5 minus I. So I is 1. So 5 minus 1 means in the first iteration 4 comparisons, right? And then my j is pointing at the 0 index, right? So I will always compare the j with the neighbor. 0 with 1, 1 with 2, 2 with 3, 3 with 4, 1 with, 0 with 1, 1 with 2, 2 with 3. So always I will compare the j with its neighbor. So I will say if my ARR of j is greater than the neighbor is ARR of j plus 1. And whatever we compare, we swap. Whatever we compare, we will swap. So here what are we? There what did we compare? Here what did we compare? We compared over here in selection sort. What did we compare? I and j. So we swapped I and j. Here what am I comparing? J and j plus 1. So you will swap that. What will you see? ARR of j will go into temp and ARR of j plus 1 will go into ARR of j and temp will go into JRR plus 1. Like this. That's all. Rest logic remains the same. So I'll copy this and let me go and make a fresh class by calling it bubble sort. Okay. And main we can copy the same. So what we can do next is, okay, main we can copy the same. This is okay. Okay, main is same, right? It's just that this part will change. So what were the changes? I equal to 1, I less than 5. So 5 is the length, right? So I equal to 1 less than 5, I plus plus, and j always starts with 0 and j less than length minus 1. Okay, or minus I rather. Because whatever is the iteration count will keep on reducing, right? And then j plus plus. And then what will we compare? We'll compare j with its neighbor and we'll swap that. So j plus 1 goes into j and temp goes into j plus 1. And we'll call the method as what? Bubble sort. Okay. Perfect. This looks good to me. So same array. Okay. So we can then just sys out over here. We can just sys out over here the sorting technique which we are using. So we can sys out bubble sort. So when I run this code, there should be some difference, right? Same, I'll copy. Same, I'll copy and paste it. The selection sort also. That we're using selection sort. Okay. So let's run bubble sort and check. Right click, run as Java application, and it works. And it works perfectly fine. I hope my screen is visible to everyone. Zoom and YouTube. See, it works perfectly fine. 67253 becomes 23567. So this is your bubble sort technique. Okay. I'll freeze this screen. Y'all can. Or maybe I'll push it onto the GitHub. Those who are practicing with me can refer the GitHub. Yeah, I've pushed this code to the GitHub and you all can refer over there. Okay, let me go and read the chats on YouTube, what these chats are. Meanwhile, you guys can practice both these. Okay. So all good. Dhananjay. Okay, Dhananjay, I'll show you how to swap two elements without using the temp. No, you can do it, yes, in either technology is not a problem. Yes, Junaid. It is verbal sort means compare the adjacent elements. Okay, yeah. Okay, so let me come back to my Zoom. So this is your bubble sort technique. Okay, one gentleman raised a question as to if I need to sort two elements without using temp, swap two elements without using temp. So how to do that? Okay, so swap two. I'm naming the class like this so that when you all see on GitHub, you all know what is there inside the class. This is also a very common interview question. Okay, this is also a quite common interview question wherein if the interview will ask you to swap two numbers, but he'll give you a condition that you cannot use temp third variable. So it's pretty easy, not that difficult. Okay, just let me know my screen is visible or not. Okay, so whenever you feel that whatever I'm speaking is not in sync with whatever I'm showing, so please remind me. Okay, because I have to deal with lots of screens. You have to switch to the programming screen, paint screen, switch to the browser, switch to GitHub. So lots of things I need to manage simultaneously. So at times there is a lag. So if you feel that, just remind me urgently. So if I have integer a as 10 and integer b as 20, so I need to swap them. So swap means they should change places. Okay, so they should change places. So my A bucket has 10 and my B bucket. So I call the variable as a bucket because it stores where data. Okay, so my B has 20. Okay, so now after the swapping, I want A to be 20 and B to be 10. Okay, so if I SOP and say over here before swapping A and B, and then after swapping A and B. Okay, that will do it in the programming. So how do we do it without using temp variable? What I'll do is I will say A equal to A plus B. So after this step, okay, after I'll show you all the iteration, the changes, the hormonal changes in each variables after each statement. Okay, so when I say A equal to A plus B, A becomes, okay, A becomes 30. A is 30 and B remains 20. B is 20. Now I want the 20 to go into A. What will I say now? A equal to A minus B. So this was A is A plus B statement. Now I'm saying what? A is A minus B. So what happens? 30 minus 20. A becomes, A was 10, B was 20. Then what did I say? A is A plus B. A becomes 30. Okay, so here I want 20, right? Here I want 20. So A is 30. So when I say A is A plus B, so A becomes 30. Okay. So now let's write B equals to, let's write B equal to A minus B. Let's write like this, okay? B equal to A minus B. So what will B become? 30 minus 10, 30 minus 20. B becomes 10, right? So after this, B becomes 10 and A remains 30. A remains 30 after this step, right? So A was 10, B was 20. I write A is A plus B, A becomes 30, B remains 20. Now I write B equals to A minus B. So 30 minus 20 is 10, 20 goes into B and A is 30. And now I want 20 in B. What will I write now? I want 20 in A now. A equal to A minus B again. A equal to A minus B. So that is 30 minus 10 is 20. So after this statement, A becomes 20 and my B remains 10. B was not touched. So I have swapped the two variables and I have not even used a temporary variable. So 10, 20 has become 20, 10. So just write this 3 line of code. Let's do it. Let's do it. Okay. Are you able to see my Eclipse screen? So integer A is 10, B is 20. This out before swapping A equals to A plus B equals to B. Okay, so let me save this and run it. It should show me before swapping A equal to 10, B equal to 20. Now let's swap it. So what was it? A equal to A plus B, B equal to A minus B, and A equal to A minus B. And then you can display after. Save it and run, and here you have swapped it. Okay, does that answer your question, sir? You had asked a question, how do you swap it? So not necessarily only in Python we can do it. Whatever can be done in Python can be also done in Java. Okay. So this was one question. Now one very interesting sorting which we will learn. Okay, let me. Okay, first let me go on the drawing board and then answer it. Very sort of interesting it is. A little bit complex, but quite interesting. Will clear your logic very much. If you try solving program of this level, no, your logic building will be very slow, very fast. So we'll try to understand complex programs very easily. That is what data structures is for. So if you have worked hard on data structures, then programming becomes that much easier for us. Okay. So now let's try to do the third sorting technique. That is the insertion sort. Okay, so I'll try to take a real-time example while explaining how insertion sort works. Okay. So to understand insertion sort, first I'll give you all a very basic example, then a real world example, and then we'll take a programming example. That the concept gets drilled in the mind. Okay. What were the numbers? Who has a photographic memory? Who can tell me what numbers we were sorting in bubble and insertion sort? Before sorting, what was the number sequence? Who can tell me? Hmm. 6, 7, 2, 5, 3. 6, 7, 2, 5, 3. Okay. And then you should know which number is at which index also. So I'll number the index also for you guys. Okay, when we'll do the programming, that time we'll do the index. What happens in your selection insertion sort is pretty simple. What it does is it sorts the first two numbers, then the first three numbers, then like this it goes on here. So it'll 6, 7, 2, 5, 3. So it will first sort the first two numbers, 6 and 7. Is it sorted? Yes. So arrange it like this. And the remaining number as it is. Then it will sort the first three numbers. 6, 7, 4. What happens is 2 comes over here. And 6 and 7 will shift one right. Shift towards the right. Shift towards the right. Okay. And 5 and 3 will be as it is. But they weren't even considered in the iteration. Then it will take the first four numbers. Okay. And then where will 5 be placed? Where its actual place is in the swap head. So 2 comes over here. And then 5 will come over here. And then again shift. 6 will shift towards the right once. And 7 will shift towards the right once. Okay. And 3 was not considered. So 3 will be at its original place. And then it will take all the 4. So in one iteration, it will take one number at a time and sort it. But where will 3 go to? Which place? So 2 and rest will keep on shifting. So 3 will come here and the remaining 2 will shift. So 5 will shift towards the right once, 6 will shift towards the right once, and 7 will shift towards the right once. Like this, they will shift. And this is your final output. So this was the basic logic in how insertion sort works. Now let me give you all a real-time use case where we can use insertion sort. Real time, okay? Where we use it at times a lot. So, when we play Uno cards, so let's say one member, the cards are distributed, and when we distribute the card, we place it upside down, right? So that the members don't see each other's cards. So these cards are lying upside down on the table. And now this player picks up one card at a time. Okay, and he will place it in his palm. Okay, so I'll just draw the palm. Please excuse my drawing. Okay, so I'll just draw the palm of a hand. So this is the palm. So I will take it in his palm. Okay, so he will place the cards in his palm one by one. So the first number which was distributed, okay, he will pick up which number now first? He will pick 7. So 7 I will call as temp. So number which is being picked, the card which is being picked from the table. Okay, so now in the temp, I will tell which card is being picked. So the first card directly will go in the hand because there's nothing to compare. So he will put 6 directly over here because there is nothing to compare because this is the first card, 6. Now the second card, 7, where should he place? Towards the right or towards the left? Because when we take the card in the hand, we try to arrange it in the ascending order. That is what I normally do. So I try to arrange it in the ascending order. So now the card which is being picked from the table is which card? Card number 7. So he will compare the card which is picked in the card which are in the hand. So now there's only one card in the hand. So this card will be placed towards the right side of. We will place 7 over here. There now 7 is placed. Now next card, what is being picked? The next card which the customer will pick is 2, right? So he will compare 2 with 7. It is smaller. So 7 will shift 1 towards the right. Then you will compare 2 with 6. It is smaller. And 6 will shift 1 towards the right. And now we have got one space. We'll try to put that card over here. What is this happening over here? It's disabled all my controls also. I did a control Z. How do you stop this infinite loop? Not allowing me to do any selection also. Okay. So now this is shifted. So now there is space in the hand and the card number 2 will come over here. Okay. Now next card he will pick from the table is 5. So whatever card is being picked from the table, I'll put in the temp. So temp is the card which he has picked from the table. Now we have to arrange it. So now he will compare it from right to left. Okay. This is the order of the comparison. So first compare 5 with 7. It is smaller. Shift this card towards the right. Then 5 is 6. It is still smaller. Shift this card towards the right. And now 5 with 2. It is greater. If it is greater, you put it over there where the space has become. You put it over here. Okay. And now let's take the last card is 3. So from the table, I will pick which card? I will pick 3. And now I want to place it. So how will I place it? So I will compare 3 with 7 first. So the card which I have got is smaller. So this 7 card will shift 1 towards the right. Then compare the temp with the next card. 6 smaller will shift towards the right ones. 3 with 5 smaller, shift towards the right ones. And now 3 with 2 is greater. Put the temp card over here. Okay. So let's say there were 6 cards. And let's say last card was 1. Okay, let's check. Last card was 1. So which card will come in the temp? Temp will have 1, right? So temp will have 1. Now compare 7 with 1. 7 is greater. If it is greater, move towards the right. 7 moves 1 step right. 6 with 1, move towards the right. 5 with 1, move towards the right. 3 with 1, move towards the right. 2 with 1, move towards the right. And now there are no more cards. Then this is the end of the palm. Okay, so here you have to also put a end of the palm. So my end of the palm has reached. Okay, and now I will put the temp over here. So like this you can. So when we play Uno, this is what we actually use while sorting those cards. We use insertion sort. Okay. So now let me try to write a 8:30 will share the attendance civilly. Daily by 8:30, Amar sir will send you all the link for the attendance. Okay. Without fail, sir will send it. So don't need to worry about the attendance link. So now let's come over here and let's try to implement the insertions. Okay. So let's copy and paste this so that we get little bit of code ready, and we can rename over here the insertion sort. We come here and we will just keep on changing the function name over here and change the function name. Okay, so let me give over here comma 1 also. So now we need to swap these numbers. Okay, I'll need the temp variable now. So this is now what you will be got to be careful of. Okay, now the first card by default goes into the hand because there is no comparison. Comparison will start from which index now? Okay, so comparison will start from index. Let's call it K. Will start from index 1 and will go till the end, which is okay. ARR is making more sense, right? ARR dot length and I plus plus. This is my for loop. Okay, sorry, K. Okay, so card starts now. 6 by default is sorted because there's nothing to compare with 6. So as I had explained, take the first number and sort it. So nothing to sort. Then take the, where is the insertion sort? Yeah. So the first number is sorted. To take 2 numbers, then sorted, 3 numbers sorted, 4 numbers sorted, 5 numbers sorted. Okay. So I guess I missed one iteration. So yeah, 6 by default is sorted. So if I take the first number, there is no need for any comparison because this number 6 compared with nothing, so it's already sorted. Then 2, then 3. So that's why my iteration actually starts from this point of where your K is 1. Okay. So where K is 1, K less than length, K plus plus. Okay. And what is your temp? The card which I am picking. So what will go in? My ARR of K is my temp. Okay. And then now what will I do is, okay, so let's come back over here. So you need to understand. So I also need to mark the end of my palm also. Okay. So let me take these. Oh yes. Okay. So let's come over here now. So this is the end of my palm. I need to keep an eye on that also. And now in my palm, I have only one card. Okay, so, and the alignment needs to be understood very clearly. So now in my palm, I have only one card, that is card number 6. Because that there was no comparison to be made. And these are my indexes, right? Index is 0, 1, 2, 3. 4 and 5. So now where is my K? My K is starting from 1. So which card have I picked from the table? Card number 7. So this card number 7 goes into the temp variable. Okay. And now my palm, that index 0, correct? So now what I will do over here is, now which is the first card which I will compare? Okay, which is the maximum index of the card in hand? Okay. So in card in hand, that will be my value for, let's say, J. Let's say that will be my J. In every iteration, I will set these two things. I will set these two things, that my temp will be the card which I am picking, and my J will be the maximum index of the card in hand. So what is the maximum index of the card in hand, guys? So if my K is 1, my J will be where? So I have picked only one card, right? So my J will be at 0 index. So I will write J equals to K minus 1. That is a, so if I'm picking up card number 7, so in my hand I have only one card, which is 6. So the index of the card in hand is 0. So J will be K minus 1. I need to do this. Okay, so I'll take a temp and I'll take a J. And J will be K minus. Okay. So far, so good. I've just started the loop and J is K minus 1. And now let's come back over here. So now what will I compare? Till my J doesn't reach the end of the palm. Till my J doesn't reach. So if J is 0 and this is my palm, and then this is minus 1. So if my J becomes negative, okay, that means there are no more numbers in the palm. So you got to check this. So once I do one iteration, you'll understand better. Let me finish one iteration, then you will know what I'm trying to do. Okay. So while my end of palm is not reached, means while my J is greater than or equal to 0. Okay. Either it is 0 or it should be greater than 0. And what am I going to compare? That my temp card. So when will I do the shifting? When will I do the shifting? When my temp is less than or equal to the jth element, right? So what is my jth element? 0. Okay. If I would have picked my card number 2, assuming if I would have picked card number 2, then would 6 shift or not? So when would 6 shift? When my palm end has not reached and my temp card is either less or it is equal to the card at J index. In this case, what I have to do now? I have to do the shifting. So shifting means card at index J goes at index J plus 1. Card at index J. So card at index J will go to card at index J plus 1. Will shift 1 towards the right. Okay, now once I've compared with 6, I have to go towards the left and I'll reduce my J ones. I'll reduce my J by 1. Once I show the first iteration, then you will understand better. This is data structure, so you have to visualize a lot of things. A lot of things needs to be visualized over here. Okay, so let's start. Okay, so let's start with this code. So my K is 1. So what is the card I have picked? I need to arrange for 7. Okay, try to understand this now. This is what is a real, and so AR of K starts from 1, right? So I should have written that for loop for K equals to 1, K less than, okay, whatever size, and K plus plus. So K equal to 1, K less than size, K plus plus. And this loop is running, and this loop will close over here. So just be a bit patient and we'll try to troubleshoot this now. Okay. So my kth card is 7, which I put into the temp. Okay. So AR of K goes into temp is 7, and J is K minus 1. K is 1, so J goes to 0. Is J greater than or equal to 0? True. So in the first iteration, this is true. So I have told greater than or equal to. And operator over here. Temp 7. Is 7 less than or equal to 6? This is false. So will it go inside the while or outside the while? So the loop will break. So where should I place the temp card? The temp card will come over here. So once the loop terminates, where does the temp card go, guys? Once the loop terminates, the temp card goes to J plus 1. Goes to where? J plus 1. So when the loop terminates, that's why I kept a gap over here. When the loop terminates, you can say the temp card goes to J plus 1 index. This will complete the algorithm. For loop completes, K increments by 1. Okay, now this cycle you should understand. This cycle you'll understand better now. So you have to be a bit patient while learning data structures. So K goes 1 iteration, K becomes 2. So what goes into temp? 2 goes into temp. Okay, 2 goes into temp. And what is J now? The maximum index of the card in hand. So if K is 2, what is J? J is 1. So J comes over here. Now let's compare. Is J greater than or equal to 0? That is true. Okay, this will just check, do I have more cards in the hand or not? So is J greater than or equal to 0? True, yes. And temp, that is 2. Is 2 less than or equal to 7? Yes, both are true. In this iteration, both are true. So true and true will become true, and it will go inside the while loop. So what it will do now? AR of J, which is 7, goes at J plus 1. So this card will shift 1 towards the right. This card will shift 1 towards the right. So the card at index J goes at J plus 1. And now as I have compared with 6, now I will move 1 towards the left, J minus minus. And J will move 1 towards the left. While loop completes, again goes up. Is J greater than or equal to 0? True. What is in temp? 2. 2 compared with 6. 2 compared with 6. Is 2 less than or equal to 6? False. Now this loop becomes false. So 2 when compared with 6. Okay. 2 less than or equal to 6 is true. Yeah. This also is true. Because what is in temp? Temp has 2, right? This card. And AR of J after minus minus has come over here. So 2 less than or equal to 6. True. Yeah. Both are true. So again, J goes at J plus 1 means index J card will shift at J plus 1. and now your j minus minus. So now the j has crossed the palm, means there are no more cards. So the j has crossed the boundary of the palm. And now in the next time, is j greater than or equal to 0? False. So when the first condition is false, no need to look for the next condition, because AND will always ask for both the true. Now as this both are, the first condition itself is false, no need to check, and the loop will terminate. And where to place the temp card? At j plus 1. So what is j minus 1? Minus 1 plus 1 is 0. So you'll place the temp card at index 0. This is the logic of insertion sort. So you got to increase your stamina of doing a bit complex programming logics. Okay, done. Loop finishes. K plus plus, K goes over here. Okay, K goes to 3. What is in 3? 5. 5 goes into temp. 5 goes into temp. And J goes back to the maximum index in hand, that is K plus 1. So J goes back to where? J goes back to 2. Now let's come again. Is J greater than or equal to 0? Is 2 greater than or equal to 0? Yes. This becomes true. This becomes true. And is temp, that is 5, less than or equal to 7? That also is true. So when it is true, what happens? You shift the card towards the right. So this card goes at, J card goes at J plus 1. So the 2 card goes at index 3. And the J reduces by 1. So J becomes over here. J comes over here. Now while loop finishes, again it goes up. Is J greater than or equal to 0? Is 1 greater than or equal to 0? True. Yes. Is 5 less than or equal to 6? True. Yes. Both true. So come inside the while loop. J goes at J plus 1. And J decrements by 1. J becomes 0. Now, is J greater than or equal to 0? True. Is 5 less than or equal to 2? This becomes false. And then where do I place my temp once the loop terminates? The temp card goes to where? Goes to J plus 1. J was at 0 and temp card goes at 0 plus 1. How was that, guys? Are you getting the concept now? And then for loop terminates and for loop increments by 1. So comes at 4. What is the element at 4? Goes into temp. So temp becomes 3. Okay, now I'm going a bit faster now. Temp becomes 3 and J goes back to the max index in hand. Max index in hand is K minus 1, that is 3. Okay. And now what am I comparing? Is J greater than or equal to 0? Yes. Is 3 less than or equal to 7? Yes. Both are yes. So what to do then? Both are yes. So what to do? Shift the 7 towards the right. Element at J goes at J plus 1. Element at J goes 1 towards the right at index 4. And reduce the J by 1. Reduce the J by 1. Okay. Is J greater than or equal to 0? Yes. 3 less than or equal to 6? Yes. So shift it towards the right and J by 1 towards the left. Is J greater than or equal to 0? Yes. Is 1 greater than or equal to 0? Yes, true. And is 3 less than or equal to 5? Yes. Shift towards the right. And shift J towards the left. Now is J greater than or equal to 0? That is true. Is 3 less than or equal to 2? False. Then put the temp card at, because this while loop will terminate, put the temp at J plus 1. So 3 comes over here. And then while increments and while comes over here less than or equal to, okay. So 5 is less than 6. There are 6 elements now. Come inside AR of K. Now what will come in temp? Temp will have 1. Okay, so now understand this. Temp will have 1. And J will go where? The max index in hand. So J will come back to 4. Now, is J greater than or equal to 0? Yes, 4 greater than or equal to 0. And is 1 less than or equal to 7? Yes. Shift towards the right. So this goes one index towards the right. So this goes to index 5. Right? Index 5. And J goes one step towards the left. Okay. Now, is 3 greater than or equal to 0? Yes. Is 1 less than 6? Yes. Both true. 1 towards the right, 1 towards the left. Is 2 greater than or equal to 0? Yes. Is 1 less than 5? Yes. Is 1 greater than or equal to 0? Yes. Is 1 less than 3? Yes. Minus 1. Is 0 greater than or equal to 0? Yes. Is 1 less than 2? Yes. And J minus minus J crosses the border now. Now no more cards to check. Is J greater than or equal to 0? This becomes false. And when the first condition is false, it won't check the second condition because it is using AND. And loop will break. And I will put what? Temp at J plus 1. What is in temp? Temp has 1. And 1 goes to now. J is minus 1. Minus 1 plus 1 is 0. And now your cards are sorted. 1, 2, 3, 5, 6, 7. How was that, guys? Okay, a bit. So you'll have to try to imagine when doing data structures, you cannot do data structures without drawing. That is my experience. So I need a parallel pen and pencil with me while learning and teaching data structures, because everything has to be visualized, how the iterations are working behind the scenes. So now let's go and code it. So what did we do? J and okay, temp. Yeah, who will tell me now what is the next? While my J is greater than or equal to 0 and my temp is less than or equal to the element at index J. What will I do? I'll take the element at index J. I'll take the element at index J and put it where? At J plus 1. Okay. And I'll reduce the J by 1. Once this loop terminates, what do you do? Put the element in temp at J plus 1. That's it. This is your insertion sort. So I take the insertion sort over here, right click on it, run as Java application. What happened? We ran out of errors. Okay, it happens occasionally, don't worry. So maybe I'll have to shut down my Eclipse and restart. Okay. So I'll shut down my Eclipse and I'll restart my Eclipse. No need to worry about it. The logic is perfectly fine. My Eclipse is shutting down. Okay, meanwhile, you all can mark your attendance, guys. And let me see what the YouTube guys are posting. So randomly, I'll keep on switching between this. Okay, so perfect. So let me. Okay, my Eclipse is shutting down. I guess I hadn't shut it down for a long time. So yeah, I'll just restart my Eclipse and then I'll run and show you all the output for. But I hope you all are getting the logic, right? Recordings will be uploaded. Amar sir will tell you all about that. So how to look for the recording. Okay, guys, my Eclipse seems to have restarted successfully. I hope you all are able to see my Eclipse screen. Okay, still some processing is going on. I guess I have made lots and lots of projects over here, no? So it seems to have flooded. I have to remove some projects from here, looks like. But you all are getting the concepts, right? And this pace is suiting you all, right, guys? Because data structures you cannot rush because you have to go step by step and show the iterations. So if I don't show the iteration, what is happening behind the scenes, people will get confused. So you should never rush with data structures. And I want you all to practice, and I want you all also to do the same iteration count. I want you all to do the same what I'm drawing over here. Whatever I'm trying to do behind the scenes, you all also try to iterate and try to learn data structure in the same way. Okay, so let me switch. Okay, now right click over here, run as Java application. Okay, you see this, guys? Insertion sort. Okay, the same program which I did over here. This logic is different. See, it's working, and I'm getting the output over 672351 becomes 16235. To do it in descending order, just change this order, just change this sign. Just change this, reverse this sign, we'll make it in descending order. So 1, 2, 3, 5, 6, 7 should become 7, 6, 5, 3, 2, 1. Yeah. Just a small, tiny improvisation, and the entire list gets sorted in descending order. So this is the least amount of code we have for sorting. Just that you have to understand the detailing inside. Yes, guys, all good. And are you benefiting from these sessions? Is there any improvement in the logic building and the understanding of the concepts? YouTube guys, Zoom guys. I hope I'm trying to make it easier for you all to understand and digest and practice. If you all feel that you all are not understanding the concept, you all can please share your reviews and feedback. So I might give a different example and then explain the same thing. So if this program is not understood or this logic is too convoluted or too complex, then I'll try to give a simple example. So I would want you all to engage and participate in the discussion and try to do pair programming with me. As I finish a program, I'll give you all a break, 5-7 minutes, and you all try to do the program in that time duration. If you struggle, put on the chat. I don't mind repeating and reiterating the same concept again and again, as long as we understand it thoroughly. That is what our primary objective is. Okay. So practice this code and let me push it onto the GitHub for everyone to practice. Amar sir has shared the attendance sheet with you all. So you all can also mark your attendance. You practice this code, guys. Okay, I'm here. If you have any doubts, you can share it with me. So last 10 minutes, I'll give you all to practice whatever coding we have done. That will come with practice, Anaya. This phenomenon that I'm understanding, but I'm not able to type, will come with practice. So what you do is, as I code, when I give you all the break, you all code the same program once, twice, thrice. When you will do that, then you'll understand it. Okay, I'll share the Zoom link once again, the GitHub link on the. So this is the GitHub link. So you can get the code from here. Okay, you want to, Junaid, you want me to share the paint screens also? Okay, I'll upload them also. Yeah, that's a good idea. Yeah, so whatever I am writing on the whiteboard, I'll push that also onto the repo. So I'll make a, okay, I have made a folder by diagrams, right? I already made a folder by diagrams. So I'll arrange the diagrams also based on the topic. So sorting. And this is which sort? This is selection sort. So yeah, this should be helpful. Nice for bringing nice, because normally what I do is I delete the paint screen once I show the example. So now I can save it and share it with you all. Yeah, it'll be easy for you all to understand things. Yes. So that's what I'm asking you all. You all try to communicate and try to express yourself so that I know what adjustments I need to make or what things I need to deliver. If you all will keep quiet, I'll think that everything is appropriate, everything is going well, and you all are understanding the concept. So the end agenda is you all should benefit from these sessions. So but really, someone please remind me to save all the whiteboard stuff and share it with you all over the GitHub. I've shared the GitHub repository to both the batches, YouTube and Zoom. Nothing different, just the same editor you will get. The editor is different. I'm using Eclipse over here. Lead code will give you its own editor. I will ask you to choose your programming language of your preference. So the question they will give you, you can choose a programming language of any of your preference. So just choose the Java editor over there and solve the program. Yeah, if you are comfortable with VS Code, you can go with VS Code. It's the editor is person to person convenience. So normally I use VS Code for front-end related programming languages. If I'm programming in React, JS, JavaScript, HTML, CSS, then my go-to editor is VS Code. But when I'm programming with Java, I go with either Eclipse or IntelliJ IDEA. So okay, I've shared the GitHub repository on the chat to both the batches. So Zoom as well as to the YouTube guys. I'll share it once again. So please take this last few minutes to practice the questions. So on a daily basis, practice. That the doubts are sorted. Okay, I've shared it to the individual. I share it with everyone. Okay. Sir has again shared the attendance sheet. So please mark your attendance. There should be the criteria for you all getting the certificate. So those candidates whose attendance is above the threshold percentage, with those will be issued the certificate. So take some time and mark your attendance. If someone has not got the link, can ask for the link to kindly share the link. So we'll try to arrange the link again. Sir is sharing the link after every 5 minutes. 8:30 onwards, every 5 minutes, sir is sharing the link. Okay, so let me push the diagrams also, which I have seen the diagrams. And now I'll push that to GitHub. So I've pushed the diagram also onto GitHub. And I'll just show it to you all once, how you all can access those. So go to the GitHub repository. I have named it DSA Mastery with Java. Go to diagrams and see. Yesterday I showed the so sorting, and all these diagrams are also here. Okay, so it's a good thing. And I have showed all the three: insertion, bubble, okay, and selection. All three are good, and the coding files also are there. So go to the main file, go to bin. Okay, always search for the code in the SRC. Go to the SRC and then you can choose. Okay, so we have day 2, and this is what we have done on day 2. Sir, can you share the link once again? One candidate hasn't received the link. So,
Yeah, sure, sir.
Vardini. So when she'll get the link. So practice these questions, guys. If you all have any doubts, first thing in the next day, bring up your doubts. That's why I was practicing this question yesterday, and I was struggling with these doubts. So can you help me out? Okay. So we can utilize the first few minutes in doubt clearance. If you all have any doubts or concerns, you all can paste it. I'm periodically switching between Zoom and YouTube and reading the comments and doubts. Yeah, all good. So try to join on time, guys, tomorrow. I saw a lot of people joining at around 8:15, 8:20. So because if you miss the basic beginning of the session, no, it becomes very hard to catch up later on. So request everyone to start joining by 7:55 itself. 7:55 only set an alarm and try to start joining by 7:55 itself.
Just 6:55.
Yeah, sorry. Try to join by 6:55, 5 minutes prior. Thank you, Amar sir. Okay, guys, then take care. Okay, Amar sir.
Tomorrow we'll not have a session, sir. So next session will be on Wednesday.
Tomorrow is a holiday?
Yes.
Okay, sir. Thank you.
Yeah.
Okay, bye, guys.
So dear students, tomorrow we'll not have any class on the occasion of Makar Sankranti and Pongal. Wishing you the same for you and your family. So thanks a lot for joining today's session, and we'll see you on Wednesday directly at the same time. So as sir mentioned, please join on the time. So enjoy the festival and let's get back on the Wednesday sharp at 7 o'clock. So till the time, take care of yourself, take care of your family, and bye bye. Have a nice day.